All right. Day 100. Kind of crazy. Day 100, and I've achieved absolutely nothing. I think I'm gonna stop after day 100. Stop just like labeling these as Leetcode streams. I think I'm just gonna do like the date because, to be honest, I'm kind of a baby for this. But I feel like labeling as a Leetcode stream, I can only do Leetcode on the stream, and because of that, I constrict myself to just this stuff rather than actual useful learning. That being said, I have yet to master Leetcode despite doing it for 100 days. That also being said, some of the days I only did it for like 15 minutes. That also being said, some of the days I did it for like 4 hours. But yeah, I think I need to reinvent it. You know, the new year's coming. Not that that's a reason to do anything, but the new year's coming. I should probably get my act together. If I don't, then I'm dumb. But yeah, I think we're gonna do day 100, and then tomorrow it's gonna be Monday, December 30th, and we're just gonna label it by the days because I don't want to. I feel like internally, for my millions of viewers out there, I'm constricting myself to just Leetcode problems when I start a Leetcode stream. So, you know, no more of that. We're gonna change things up. I think we're gonna reinvent it. But for those of you that have been here since day one, thank you. So yeah. Dang, day 100. And I've done nothing. I've done absolutely nothing. Oh, what just happened to my chair? Come on, get this hood out the way. Okay. Oh, that's what the heck? Wow, I've never had that happen. Okay. So, to celebrate the 100 days I've been doing this. Wait. To celebrate the 100 days I've been doing this, I've decided to punish myself with some dynamic programming. Yeah. It was either that or regex. I'm not looking forward to this. But yeah. Okay. Climbing stairs. This is just Fibonacci, I'm pretty sure. Wait, is it? Oh, yeah. It is. So if n equals 0, we're going to return what? 1? For n equals 2, I has to be less than n plus 1. Equals what? Wait, am I dumb? Something like this, right? Dude, I forgot. How do you forget the Fibonacci sequence? See, this is why I got it somehow, but this is just... yeah, it's painful, man. It's painful. 100 days of Leetcode. What does this come up to? Literally nothing. Literally nothing. Oh man, let's get this. I gotta bounce in like 45 minutes too. But I hate this stuff. I think it's +1. And I think this may be... Yeah, this is probably going to be math.max, cost 0, cost 1. And then incur or max equals math.max, cost I, plus 2 before, or 1 before, and then 2 before equals max, 1 before equals 2 before, return 2 before. That didn't work. It might be like... Let's see. That's crazy. That was my jaw. That was a big pop. Alright, we're getting distracted. I think we can actually do like... where it's like int max equals math.max, cost I plus 2 before, and 1 before. And then 1 before equals 2 before, and 2 before equals max, turn 2 before. Or is it the opposite? It might be 1 before equals max, 2 before equals 1 before. It's definitely that. Or not. Oh, it's min. Okay, never mind. So we want to do that plus the 2 before. Yeah. So, because 1 before will be the adjacent. And then And then what? This also has to be min. So 10 plus 0 or 0. So it'll be 0. Then it'll be 15 plus 0. Wait. So when we move 1 before becomes 1 before becomes min, and 2 before becomes 1 before. So 2 before equals 1 before, and then 1 before equals min. And then we're going to return one before? It might be the case. No, it won't. I'm just like accepting that I have memorized all the DP and I don't like fundamentally know any of it. So if cost. Okay, you know what? I'm gonna do something here. This makes sense. This makes sense too. We want to do the +1 because we want to process all the values, and we're doing a lagging iteration. What? I need to go bathroom. Oh my. Okay, good. I was about to say. One before. I think a part of the pain of of the dynamic programming is not wanting to do it and hating dynamic programming. I suck at. I am absolutely awful at dynamic programming. Can you help me out? I also get like the GPT can be. This is the smallest prompt ever. What is it saying? GPT can be nice, but I kind of get used to just teleporting to the answer instead of reading everything. I feel like when you read everything, you understand it a lot better. Let's get the hang of recognizing patterns and breaking problems into subproblems. It becomes much more manageable. To get, we can understand overlapping subproblems, optimal substructure, memorization versus tabulation. Solve problems step by step like Fibonacci numbers, knapsack, and longest common subsequence. Build templates. Develop reusable approaches for DP problems. Analyze complexity. Practice deriving time and space. That doesn't help. The problem is I don't know how to like identify a DP problem in the wild. Like these, because I know they're DP problems, I can solve them like that. But yeah, if it's a wild DP problem, I don't know. Yeah, so what's nums dot length? It's at least 1. Nums or return nums. No, it's fine. I did not mean to do that. How stupid did that look? How stupid did that look? That looks so stupid. I meant to shake everything in the, but I forgot there's no lid. That was so stupid. Everything, like, there's so much water on my desk now. Oh my gosh. How much of an idiot am I? My monitor is just destroyed. I need to clean my monitor anyways, but not with like drinking water. Let's get this microphone out the way. Jeez, bro. Well, this is off to a great start. I literally splashed everywhere. Everything's wet. All this nice equipment, all wet. What am I doing? I am so dumb. Alright. Well, now that that's resolved. Jeez, bro. Wow, how much of a dummy do I have to be to do that? I need to disconnect my keyboard. Because everything's wet. Freaking expensive keyboard. And I just splash water on it. There's keyboards that advertise themselves as like waterproof. I find that funny. Thank God there's so many components to my keyboard that if I just like doused it in water, it probably would be fine. Because the water would have to go through so many different things to even damage anything. I also need to switch this keyboard because I'm tired of it. Okay, we are back in business. Hopefully. Hopefully something didn't break. There's water everywhere. Jeez. Whatever. House Rapper 2, like, this ain't a crazy problem. It's the same thing. I'm not doing this. It's the same thing as House Rapper 1. Oh, I hate these problems. I absolutely hate these problems. They're so awful, man. They're so awful. Like, this requires so much brain power. I can't even talk about it. I just have to type it. Oh, man. %34% acceptance rate is crazy. There's two palindrome ones, and they're just awful, bro. They're just awful. It's either a 2-pointer or something like this. Yeah. I don't know how to do this. I don't want to do this. I don't want to do this one either. This one's awful. Oh my gosh. Oh, the coin change. That's the only cool one. Greedy. I don't even like greedy either. These two, I don't even really know. Oh my gosh. It's almost like it gets harder as you go down. Oh my gosh, I do not want to do this. I'm gonna do graph one. I don't even remember how to do this. I do. I just like, oh my gosh, this is so annoying. So you make an adjacency list. I actually don't think this is how I'm supposed to do it. Pretty sure it's a map. No, just map, I think. Is it this? It's definitely not right. There's something wrong here. Yeah. There's definitely something wrong. There's too many parentheses. Is that really it? Wow. This is hard too. Oh my gosh. These last ones are very hard. We need a comparator because there's no way to compare them. I don't. plus equals cost. Dude, this is such a bad session. I don't know anything. It's either I think it's Prims or Bellman Ford. Yeah. I probably wouldn't have gotten that. See, when I see this, it makes sense now. I don't know why we keep track of edges, though. Yeah, it doesn't change anything. See, now that I see this, I can write it all down now. Watch. So we want to keep our output, and then we want to keep the amount of edges we have. And then we are keeping track of connected edges. So we're going to make an array of Boolean. And then we're going to make a priority queue. That stores the stores pair or an array of integers, and we're sorting it by the distance between the most recent point and the next point. and then we do breadth first search. So we get the current value. The cost will be the first value, and the index will be the second value. And if we have visited this current index already, we're going to continue. We're going to ignore. Otherwise, we are going to add the cost to output and mark this as visited. Then we're going to go through each of the nodes, and if we haven't visited, or if we haven't connected this node yet, this edge yet, if we haven't connected this node to anything, that's actually interesting. We have n. I did not expect this, actually. I know to write, I just want to understand it. 1, 2, 3. Oh, these are points. So they're not technically edges. Okay. Yeah, I'm so dumb. It says points there. So I was mistaken. N is not the number of edges. N is the number of points. So we have 0.1, 2, 3, 4, 5. Or if it's 0 index, it's 0, 1, 2, 3, 4. So if we've connected that point, yeah. So this is keeping track of the connected points. Cool. We calculate the new cost. And it's going to be points index 0 minus points I 0 plus, it's the Manhattan distance, right? Points index 1 minus points I 1. And then we're going to offer to the queue. New cost and I as in the index. And return output. Yeah. Cool. Cool. So that's prims. That's not Bellman-Ford. This is Bellman-Ford. Bellman-Ford involves like the relaxation or something like that. You have to relax each of the edges. Okay. Which one's the origin node? Is it K? Yeah, it sounds like K is the origin node. What's N? N is the number of nodes. So int delays equals new int N. Arrays.fill delays with integer.max value. So we're yeah. So we track the distance from the origin node that it takes to get to each node through this delays array. And then the starting value for, I think it might be n plus 1. Yeah. So the starting value for delay, and okay, it's n plus 1 here because K is not 0 indexed, but the delays array is. So delays 0 will always equal integer.max value. So yeah. So delays K will equal 0 because that's where we start. That needs to be here. So then we iterate through each time. what is, let's see, int source equals time 0, int target equals time 1, int delay equals time 2. So these are our values. Does relaxation happen while we iterate, or do we iterate do we relax every time we iterate? Let's see. What would make sense? Let's not worry about relaxation right now. So if delays the source does not equal the max value, and then delays target will equal math.min delays target. Actually, let's just, and delays target is less than delay. No, delay is less than delays target. Delays target equals delay. Yeah. Something like this. I'm missing the relaxation part. Yeah. Alright, I got 8 minutes, so I'm gonna look. I've been looking at everything, bro. It was really bad. Yep, we relaxed there. Okay. So let's just, for int I equals 1. So we do I equals 1 here because we only want to, or there's no point in relaxing more than n minus 1 times. So honestly, should be this. That's a little more intuitive because we're processing a node. So n minus 1 nodes are the ones we have to process. N times int source equals time 0, int target equals time 1, int delay time 2. If delays source equals into, does not equal, right? Yeah. Delays target, oh wait, and delays target is less than delays source plus delay. Oh, that's what I was missing. Delays target equals delays source plus delay. And then we track the elapsed time. Oh. Oh. Oh, I see. Oh my gosh, there's a reason why we have to do this. There we go. Uh-oh. Oh, there's a reason why we have to do this too. Okay, I stand corrected. Actually, no, there isn't. But what am I doing wrong? Max value delays n plus 1 k 0 plus plus. I'm so dumb. Okay, we got time to write it again. So, okay. So we're going to keep track of the current delays. I'm going to fill the delays array with integer.max value and then set delays k equal to 0. And then for in I equals 1, I has to be less than n I plus plus. For int time and times int source equals time 0, int target equals time, int delay equals time 2. If delays source does not equal integer.max value and delays target is greater than delays source plus delay target equals delay source plus delay into elapsed time equals 0 for int I equals 1, I has to be less than or equal to n I plus plus. If delays I equals integer.max value, return 1, elapsed time equals math.max elapsed time, and delays I, turn elapsed time. Yeah, there we go. Okay. Cool. Alright, I need to change this because I'm going to stream later today, so this is going to be part 1. Alright, so we clearly have a lot of work to do. Yeah. This bottom stuff, like intervals, greedy, advanced graphs, that's fine. Just this little section right here is what's killing me, unfortunately. So I need to brush up on these for sure. All of this is fine for the most part. Yeah. Dang, bro, dang. I will be back.